So in this video, we are going to go over group assignment 1 that details recursion, stacks, and linked lists for Dr. Rizk's Computer Science 2430 class. So on the left, you'll see the group assignment document, which is going to instruct us in what exactly we need to do. And for the introduction, we are told that we have these twin siblings named Sarah and Alex. And each of them have part of a piece of jewelry, and each of their jewelry pieces has a bunch of encodings that are in the form of arithmetic expressions, and we're supposed to decode both of their jewelries in order to get the secret password for them to be able to find the treasure. So we have a list of assumptions that we are told that we can make. We have input files that can only contain a maximum of 100 expressions. This honestly isn't going to really make a difference when we get to the programming portion. It's just supposed to give you an idea of the runtime efficiency that you need to have. We are also told that an input file could contain empty spaces between expressions, and we are able to ignore these lines. And so we have to make sure that we take that into account when we're creating our main. We're told that there is going to be no space in each expression, and that in each expression only digits 0 to 9 will be used, and each operand will be a single digit, which is going to be helpful later on in one of the other functions that we're going to write that's actually going to do the decoding. The only two operators that we're given are plus and minus, so we don't have to worry about multiplication and we don't have to worry about division. And we're also told that we have 3 different sets of parentheses. We have the parentheses, the curly braces, and brackets. Now we are actually going to be given the setup of what our program is supposed to look like. We're told that we have a list of arithmetic expressions along with other types of information in an input file. For arithmetic expressions, each line will be considered a single expression, and you first need to decide whether or not the expression is valid before you proceed to decode the expression. An expression will be invalid if opening and ending parentheses do not match. You are also told that the pieces cannot be assembled unless each piece has been entirely decoded on its own. So in other words, you can't insert all of the decoded numbers to only one linked list during the decoding stage. Instead, you have to make a separate list for each of the twins and store the jewelry pieces on there respectively. When it comes to decoding the expressions, we are told that the result of a valid expression gives you a number, which is either a part of the passcode or an instruction. During the decoding, we are going to add each non-negative number to the appropriate linked list, and again we have one linked list for each twin. So in the case that the expression is evaluated to a negative number, we're going to find the first occurrence of the positive counterpart from the linked list, and we're going to remove that number. And we're also always going to start from Sarah's list and look for the number there, and if it's not found, then we look for it in Alex's list. And in order to obtain the final passcode, we're going to merge the two linked lists. Sarah and Alex hold the first and the second halves of the jewelry. So we need to be able to add Alex's list to the end of Sarah's list after we're done decoding. And then we also have to keep track of the total invalid expression count. And if the invalid expression count is greater than 0, it will give us an instruction that tells us to delete an element at a location with the number as the index. So if we have 5 invalid expressions, then we delete the number from the merged linked list at index 5. And then at the very end, we have to reverse the resulting list. And very importantly, we are told that all linked list operations have to be recursive. Points will be deducted if we use iterative implementations. And then here are a few example input files to give you more of an idea of what you're supposed to do. I'm not really going to stay on this part for too long, but if you want to test out the program, here are the examples that you would use for that. This one is for example 2, and then this one is for example 3, and then this one is longer, so scroll down a little more. Alright, and you actually don't need to keep track of this at the very end that says treasure unlocked. That's not actually going to be included in the coding. That was a typo on their end. Alright, So the first thing that we're going to need to do is to kind of structure what are the files that we're going to need for this. As always, we're going to need our main.cpp file. We're also going to need a linked list file, which is going to hold the decoded expressions. And you can kind of tell that that's what we're going to need because the name of the group assignment contains linked list. And then we're also going to need our stack header file, which is going to be where we actually decode the expressions themselves. It's going to be where the bulk of the work is made. And again, you can tell we need it because it tells you in the title that we do. And we also have our struct header class, and we're going to make this a separate class simply because we want to make it accessible to both the stack and the list. And I personally have had issues in it being able to access both when it's contained in one of the files. So we're just going to put it in a separate class for that reason. Alright, so before we can get to programming the linked list, the stack, or the main, of course the first thing we need to do is we need to create a basic template struct to use for both the linked list and the stack classes. And this is just a normal struct that you would normally use for linked list, just has to be of template type, or type template, sorry. And again, we're going to create this in its own header file so that it can be accessible to both the linked lists and the stack classes. Alright, so like we said before, the most important portion of the of this program is going to actually be contained in our stack class, and so it is actually going to be where we start the programming, especially since the linked list class has to work off the stack class in order to be able to operate correctly. So all of the functions that you see right now on the screen for the stack class are underlined because they are the basic functions for any ADT. You should have these included almost every time. So obviously we have our default constructor. We have an isEmpty function to check if the stack is empty or not. We have a peek function to be able to see what the element at the top of the stack is, but not remove it. A push function to actually add elements to the stack, and of course the pop function to remove elements. And in addition to that, in addition to all of these base functions that you always have to have, we are going to need to include a function for check validity, which is going to check the validity of a specific expression. Because if you'll recall in the document over here, it tells you an expression will be invalid if the opening and ending parentheses do not match. So if the expression is invalid, there's no reason to continue on and to try to evaluate it. You can't do it because it's not a valid expression. But if it is, then you'll know that you're supposed to actually evaluate the expression. In addition, we also have these two other functions. We have an int to post function, which is going to convert from infix to postfix notation. So after we go through our check validity function, if we find that the function is valid or the expression is valid, then we need to call the int to post function on it and convert it from infix notation to postfix notation. And the reason we do that is mainly just because it's far easier for your computer to actually be able to evaluate postfix than it is to evaluate infix notation, and it's easier for you to program as well. And then ultimately, after we convert it to that notation, we actually have to call the evaluate function on the postfix expression that we have just created. And that's going to actually go through and evaluate the arithmetic expression and give you your final integer. Alright, now that we can presume that we have our stack class written, we're going to actually look at the functions that we're going to include in main. And when we're actually writing the code, we're going to hop back and forth between main and the stack and the linked list class as you normally would, but for the sake of this overview, we're going to have them separate. So the first thing we need in main is a while loop using getLine to be able to actually get the input from the file. And we're going to go ahead and ignore empty lines that are given to us because that's what our assumptions on the document says. It says that input file could contain empty lines and you have to be able to ignore them. We're also going to create two linked lists, one for Sarah, one for Alex, which is where it's going to store their respective decoded functions. And we're also going to have an add to list function. And our add to list is the one that's going to take care of this part of the document, which is that if the decoded number is non-negative over here, then we know that the number should be added to the twins list. But if it's negative, then we have to add it to a special stack that we make, where I just call it negative stack. It's just a negative stack to store negative numbers, because after we finish the decoding, that's when we have to start removing the negative numbers. I don't know if the document is explicitly clear on that, but it needs to be done at the very end. And after that function, we're going to have a while loop that is going to pop all of the elements from negative stack, which again contains all of the negative decoded expressions, and it's going to remove those respective elements from the twins lists. Again, this is all going to be done after the lists have been originally created. And then the next part is going to be actually merging the lists, which is going to be a function that we're going to call on from the linked list header file. We're also going to have to remove at the invalid count, which again, if you remember this part of the PDF, it mentions that, oh, sorry, the PDF is being weird. It mentions that you have to count how many invalid expressions you find, which again is from the check validity function from our stack class, and if it's more than 0, you have to remove at that index of the linked list. And then after we do that, we have to reverse the list, which is again going to be a function in our linked list class, and then we're going to print the lists, which is also a function in our linked list class. Alright, so after we've got our stack set up and our main set up, we have to actually take a look at our linked list class in order to be able to set that up, because that's also extremely important. So we have to have our default constructor as per usual, and again the underlined ones will tell you what is essential to include. We have to have our default constructor, our getHead function, so that we can access the head value from main, which is going to help us in calling functions. We have an isEmpty function, checks if the lists are empty or not, and a print function to actually print the list. And we will also need to add an add and a delete function, but they're going to have to be slightly different from how we normally do it, because this is a special linked list. So our add function is going to be adding to end specifically. We're not going to add to the beginning or the middle, we're going to add to the end. And then we're also going to have 3 different delete functions. We're going to have a function to delete at the beginning. We're going to have a function to delete a specific value, which is going to traverse through the linked list, look if it has the value or not, and if it does, delete it there. And this is going to be used for, again, this part of the program where it wants the count of the total invalid expressions to delete at that count. And then we also have a situation which is going to delete at a position. And I actually flipped my explanations for delete val and delete at position. Delete at position is the one that we're going to use for this part. Delete val is going to be the one that's going to be used for this part, for the negative numbers. So sorry about that. Alright, and so then the other part is going to be these last 3 functions that you're going to see. We have to merge the lists, which is in this part over here. It tells us that we have to merge our linked list, and then we have to, oops, I did not mean to highlight that. We have to reverse the linked list, so again we have a function for that, and then we have a traverse list, which is going to actually, it's not necessarily, but it's going to help us simplify some of the codes, some of the code for some of the functions in the linked list. It's just going to help you traverse the list pretty quickly instead of copying and pasting that code again and again. Alright, and again, like the document states and has highlighted, all linked list functions that we implement have to be recursive. They cannot be iterative, because you would get points off for that. So as we can see, the first thing that we're actually going to need to do is to create a struct that is of type template. And we want it of type template because later on in our code we're actually going to see that we need to make like stacks, linked list of type string, type int, etc. And so we just wanted to make it type template so that we're able to do either or pretty easily without having to make many changes or to create a new struct. So we're going to head over to our Visual Studio, and we're going to put our struct in a separate class, simply just because we want to be able to access it from both our linked list header file and our stack header file. So this way we can just make it so that it's pretty easy to get to. And so because we're using templates, we have to remember to include our template header, and we're just going to name it T, because that's fairly easy to use. And we'll call our struct node. And our struct should contain two things. It should contain a place to store our data, which we're just going to be whatever our data is going to be, like either the expression, or we're going to have whatever the expression evaluates to. For our stack, we're going to have it store the expression itself. So I'm going to just call that digit. You can call it whatever you want, doesn't really matter. And then we also have to make a pointer to the next node. And of course, this pointer also has to be of type T. And that should be all that we need for our struct class. Alright, so then we have to actually move on to the stack, because that's the first part of our code that we want to implement after we have a struct set up. And the first thing we need to do with the stack is we need to create a basic stack class that has all of the base functions that we mentioned before. So I'll just pull up my Visual Studio again and head over to my stack class, and we can start setting this up. So of course we have to remember to include our struct class that we just made. That's not correct. Give me just a second. Okay, let me save this real quick as well. So we've included our struct, and we also have to remember to include our string, because we're going to be using that in here. And we also need to include our string stream, because later on when we're doing postfix, prefix conversions, or not prefix, but postfix conversions, we're actually going to use this. And then using namespace std, and then because we're using templates, again, we have to remember to create a new template, and we can just call this T again. And then we can start setting up our class, which is of type stack. And then for our private variables, and we need our public variables. And so because this is a stack class, we need to create a top. We need to create a node of type top. So again, we're using templates, so we have to remember to include that within our creation of the node. And we'll just call that top. And then for our public, we have to have a few functions for the base stack function. The first one is going to be the constructor. And in the constructor, we just want to remember to set our node top to null. And then we need a function to tell us if the stack is empty or not. And this is very easy. It just returns true if the top is null, and if it's not null, then it will return false. So we can just check for that pretty easily that way. And then we need a peek function. This will be useful later on, which will return what the top element is, but is not going to remove it from the stack. And we have to remember to check whether it's empty first or not, because if it's empty, then this will run an error, calling our peek function. And if the function is not, or if the stack is not empty, then we have to return whatever the value that is saved in the top is. Alright, and then we're going to actually need a push function. Oops, that's not correct. Push function. And this will take in a value of type T, and then a pop function, And then we're also going to need, we actually do not need a print function for this because our stack is not going to print any elements. It's just for conversion purposes. So we'll actually go ahead and fill in our push and our pop, and afterwards we'll be ready to go and start on the actual math part of this. So for a push function, we have to declare a temporary node. We'll call that temp, which is the new node. Again, of type T, that's very important. Don't forget to include that, or else your program is going to run errors. And then we need to set whatever the digit in the temporary node is, or whatever the value in temporary node is, to the value that has been passed through our parameters. And then we want to make sure to check that the stack is not empty, because that way we'll have it so that the temporary node points to the top. And then if the stack is empty, then we actually need to make sure that we set our temporary node, the next of the temporary node, to null, which it would still do either way, with or without the if statement. And then finally we have to remember to set our top equal to the temp variable that we just, to the temp node that we just added. So that should actually be all for a push function. And then now we have to actually do our pop function, which we have to of course check if the stack is empty or not, which is normally the first thing you want to do in any function. Because if the stack is empty, there's nothing you can pop. There's no node to remove. But if the stack is not empty, then we have to create a temporary node to store the value that we're going to remove. And the value we're going to remove, because it's a stack, is always going to be the top value. So we'll just set that equal to top. We need to make sure that we set our top equal to the node that is after it, because the top is going to change. We have to have a new top after it's popped. And then our temporary node should now point to nothing after that, because it's going to be detached completely from the list. And then we can now delete the temporary node. And that should be all the base functions we need for a stack class. Just the constructor is empty, a peek function, our push function, and our pop function. And this will be a fully functioning base stack class. Alright, and so now that the base stack class is set up, we can finally move on to the actual math part, which in order to do that, we have to first check the validity of the expressions, because if the expression is invalid, then we cannot convert it to postfix and then evaluate it. But the expression is valid, then we can do that. And we also have to remember that we have to be counting the number of invalid expressions that is in our code for use later on in our program. So we're actually going to make it so check validity returns a bool, and it returns true if the expression is valid, returns false if the expression is invalid. So that way in our main we can increment our invalid expression count. So in our main, or sorry, not in our main, in our stack class, we can actually create a new function that we can call check validity. And again, this is going to return bool. And this is going to take in a string. And the string is going to be whatever the expression that we're going to check the validity for is. And so what we're going to need to do is we're actually going to have to go through every character that is in our expression and check that an opening parenthesis has its respective closing parenthesis. An open bracket has a respective closing bracket, and so on and so forth. Because if we have a bracket if we have one open bracket but no closing brackets, then the expression is invalid. If we have no open brackets in one closing bracket, the expression is invalid. So we have to make sure that those brackets line up with each other the way they're supposed to. So the first thing we need to do is set up our if statement, which will go through every element in our current string. And now we have to set up an if statement. I'm sorry, I said if statement first. I meant a for loop that goes through every element in our current string. Now we have to set up our if statement, which is going to check if the element at I is equal to, that's a curly brace, I believe. There's three different types that we're supposed to check. There's a curly brace, there's a bracket, and then there's a parenthesis. And so we have to check for each of those. Which is going to be a little bit of a long if statement, but it will work. Okay, and I realized I did not put enough equals signs. You have to remember for if statements we need 2 equals. And if we have, if we find that we have an open bracket, what we're actually going to want to do is we want to push this on our stack, because this is where the stack comes in pretty useful for this. Whenever we find an open bracket, we push it onto the stack. Whenever we find that we have a closed bracket in our current string, we are actually going to check to see if there's a respective open bracket for that on the stack. So if I find that I have a open parenthesis, or I'm sorry, I have a closed parenthesis in my string, I check, is there on the stack, the top element, is that a open parenthesis? And if it is, then I continue on. If it's not, then our expression does not match up. Our brackets don't match up. So that would actually mean that our expression is invalid and we could stop the program as it is. So this is actually going to be what is our if statement, or sorry, our else if statement. We're going to check if we have a closed parenthesis, closed bracket, closed curly brace. It's a little bit long. A little bit long. Okay. And if it is any of those, if it's any of those closed parenthesis, closed bracket, whatnot, we have to double check. We have to actually make a very long if statement for this. So what we're actually going to have to do now is we need a few different things in our if statement. We're going to actually check for what would make the expression invalid. There's multiple things that can. First thing we have to double check is if the stack is empty. If the stack is empty, then that actually means that nothing was ever pushed onto it. So that basically means that in a situation where we don't have any open parentheses, but we find that we have a closed parenthesis, that's invalid. That's what our is empty would check for a situation like that. But if it's not empty, then we have to double check that the top node of the stack is an open parenthesis that matches with the closed parenthesis. So I check if current at I is equal to the open parenthesis, and the peak function is not equal to the open parenthesis, or the closed. I'm sorry, the current at I is equal to closed parenthesis. That's a closed parenthesis, not an open parenthesis. And then we're going to check, and our peak is not equal to the open parenthesis. It can get a little confusing. Because remember, this if statement is actually going to return for when it's invalid, and it would be invalid when the parentheses don't match up. And then we're actually going to need to do this for all the rest of them. So I'm just going to copy and paste this because it's going to be the same setup. And then just change, that's incorrect. And then I can just change what my parentheses are. Okay. Alright, and so that should actually be correct now. And if it's any of these, any of this part of the if statement, very large if statement, but if it's any of this part of the if statement, then we want to make sure that our program returns false. Otherwise, if our check tells us that current at I is equal to the open parenthesis, and you don't actually need the whole else if statement, you can just make it an else statement, but it might be easier to follow the logic like this. And again, we can copy and paste this. This is just, again, this part of it is going to tell us if we find that we have a closed parenthesis, is there a open parenthesis that matches up with that? And if so, we're actually going to go ahead and we're going to pop it. But let me just change this, change that, this, and then this. And again, you don't need this whole else if statement. I'm just writing it out so maybe the logic will make a little bit more sense. But your if statement is going to basically take care of most things, so you would just need an else statement to take care of when your expression is valid. And so this is going to run through every single element of your current string. And by the time we're done, the size of the stack is actually what is going to indicate to us if the expression is valid or not. If the amount of opening parentheses and closing parentheses match up and the types match up, so the expression is valid, then there's nothing going to be left in our stack because we popped everything. We push it if it's open, we pop it if it's closed and it matches. So our expression can actually go ahead and we can return if the stack is empty. So again, if it's empty, then it's valid. If it's not empty, then it's invalid. And so that should actually be it for our check validity expression, our bool check validity expression. Alright, so the next part of what we need to do for the stack class is the conversion of our valid expression from infix notation to postfix notation. And infix notation is just like, for example, I have 2 plus 2. My operator goes in the middle of the two operands or that I'm adding together. Postfix notation means my operand goes at the very end. So I would have 2, 2, and then plus. And so we actually want to do this conversion because it is far easier for your computer and for you as the programmer to make it so that your mathematical expression evaluates from postfix than to make it evaluate from infix. Now, this conversion is actually the hardest part of this assignment, the conversion of infix to postfix, and it's specifically difficult because we have the presence of parentheses, which means that we have to heed order of operations, which we would not have had to do otherwise if it were just the plus and the minus. And that's where most of the tricky part is going to come in. Alright, so now it's time to write this function, and real quick I realized that in my check validity function I actually did not put the return statement within the function. I put it outside, which is a bit of a problem, but now my function is correct. So moving on to our infix to postfix notation, I'm just going to call it into post, and it's going to take in a parameter string current. And we're actually going to have it return a string because we want it to return an expression after it has been converted so that we can do the evaluation portion in a different function. So we're actually going to make a new string. I'm just going to call it post expression. The name is a little lengthy, but you can call it whatever you want. And it's going to be an empty string. And this is actually where we're going to save the postfix expression as we build it up. And then we're actually going to have an integer. I'm just going to call it prespara. Just means that there are present parentheses. because we have to keep track of how many parentheses we have in order to be able to do this function correctly. And right now, because we haven't started looking through our string yet, we can just set that to 0. And when we find a parenthesis, we'll increment it. When we don't, it will just stay the same. So now, similar to what we did in our check validity expression, we need a for loop to go through each element in our current string. And because we're going to scan what the character in that portion of the string is, and based on what we get, we're going to have it do a specific thing. And we need to have a series of if statements to check what that specific character is. We need to check if it's an operand or operator, if it's a plus or a minus. We have to check if it's an open parenthesis, we have to check if it's a closing parenthesis, and then if it's a number. And if you'll recall, in our group assignment document, it actually stated that we are never going to have any number that's greater than 1 digit. So we know that if I scan for whatever character is at integer I, that's what the number is. It's never going to be 22, it's always going to be 2. So we don't have to worry about anything weird going on there. So in our first if statement, we can double check for if it's an operator or an operand. I'm actually not entirely sure which is which, but if it's a plus or a minus. So if it's a minus or plus, or if it's a minus. And we'll fill in this if statement in a little bit. We'll just go ahead and outline the rest of the code first, because the actual logic is a little bit complex. So here we'll have it so that it checks if it's an opening bracket or parenthesis, and we're actually going to go ahead and copy and paste that again. Okay. And then we're going to have another else if statement where we check for the opposite. And I'm going to just copy and paste this as well. We're going to check if the brackets, parentheses are closed. Okay. And then we'll have an else statement, which is basically just going to check if our current character is a number. And so the logic behind this is basically, if the character that I have is a plus, minus, or parenthesis, it needs to be pushed onto the stack. A little bit similar to how we did our check validity function. If it is a number, then we add it to the string, the post expression string. And then, of course, we have to be able to, move our plus, minus, parentheses, whatever. We actually don't need parentheses in a post expression string. Those are going to be removed. Those are just used to tell us what the order is going to be. We're going to end up having our plus and our minuses in our post expression string as well. And we have to know when to remove this from our stack and add them to our string. So the easiest part of this is to actually start from the else statement, because the else statement indicates when we have a digit. And when we have a digit, we need to add it to our post expression string. So just plus or minus current at I. Alright. And we're going to go ahead and fill these out. But really quickly, we also have to remember that this function is supposed to return a string. And the string it is going to return is going to be post expression. That's going to be our postfix conversion after we're done with everything. Alright, so the first thing we need to do is we need to address when we have a plus or minus operator. Now, what we need to do with the plus or minus, normally if we didn't have parentheses present, is we would go through each character in a string. If it was a digit, we would add it to the string. If it was not a digit, if it was a plus or minus, we would push it onto the stack, and we would pop whatever was on the stack before. So if I had a plus on the stack before, I'd pop that, I'd add it to the string, and then I would add our new operator in place of them. So because we have parentheses, this becomes a little bit more complex, a little bit more complicated. But the kind of main gist of this is that we need an if-else statement within the if statement that I'm in right now, which will basically check when the stack, when you need to just push the operator on there and that's all you need to do, versus when you need to pop what operator was on there before and push the new one on there. So the first thing we are going to need to check for is if the stack is empty, because if the stack is empty, then you know that you need to push the operator onto there no matter what. Another thing we need to check for is when the number of parentheses that we have present is not equal to 0. Because again, the way we treat the way we're going to treat our operators when there are parentheses present is going to be different. When there's parentheses present, what's going to end up happening is that everything within the parentheses needs to be popped before, needs to be added to the string before you continue on. So it doesn't matter if you have a plus that came before a parentheses and then a minus that came within the parentheses. You know for a fact that minus that came within the parentheses has to be added to your string before the plus that is outside of them. It's a little weird. I would suggest if this is a concept that is strange, watch a few videos about this. It's kind of difficult to explain it without a visualization. Watch a video that will tell you how to treat parentheses in a situation like this, because this was definitely the most challenging part of this assignment, was that kind of understanding. But in this situation, all you need to know is because we are treating our parentheses differently, or treating our operators differently in the presence of parentheses, we have to check if the number of parentheses present is not equal to 0. And then we also have to check as well, it has to be one of these conditions, either it's empty or the number of parentheses present is not 0. And it also has to check if our peak is not equal to an operator. So if our peak is not equal to an operator, that will tell us that our peak is actually equal to a parenthesis. So again, the whole point of this is basically this if statement is supposed to tell us when we can't pop the previous operator and add our current operator instead. This is when we have to treat it a little bit more special. And all we're going to do in this situation is we're going to push our current at I onto the stack, and we're not going to pop anything. We're just going to add it to the stack, and that's going to be that. So again, what this is going to do is, in a situation where a stack is empty, there's nothing that you can possibly pop, so your operator has to go onto the stack. Or in a situation where you have parentheses, and you know that your parentheses is present in your stack, then you have to make sure that you're not popping anything that is outside the parentheses. You're not adding any operator that is outside the parentheses to your expression string before you add the operator that's inside your parentheses to your expression string. That always goes first. Again, a little bit weird if it doesn't make much sense, which I doubt it will. See if you can find a good explanation, good visualization online to help you out. This is mainly just for the coding portion. It's a little hard to explain the concept itself. But then we move on to our else statement. And our else statement checks when we actually want to remove the operand that comes, that's already on the stack, and replace it with our new operand. So we actually need to go ahead and we're going to add the operator that's already on the stack. So we're going to have to use our peek function for this. The operator that's already on our stack to our post expression string. Then we're going to pop it off the stack. And then we're going to push our current operator onto the stack. And again, I'm not entirely sure the difference between the operator and operand. I'm using them a little interchangeably, so if it doesn't make sense, that's why. But I mean the plus or minus in this situation. We're going to add our plus or minus to our stack. And so this is going to be all we need to do for our plus or minus, and then we have to actually move on to what happens if we have a parenthesis. And in a situation where we have an open parenthesis, and remember, this is working with a valid expression. So if it's a valid expression, your parentheses are always going to line up. If you have an open parenthesis, you'll always have a closed parenthesis. So we can assume our pres para integer is going to count the pairs of parentheses, not actually the number of parentheses themselves. So if I have, you know, an open parenthesis and a closed parenthesis, that counts as one pair, so our pres para would be 1. So when we have an open parenthesis, this is when we're going to push it onto the stack. Because again, we push anything that's an operand or anything that's like a plus or minus in a parenthesis onto the stack, and then we increment our pres para integer. So now we know that we have a set of parentheses, and we also have the parenthesis actually on the stack. And then we have the last part of this code, or the last part of our if statements, which is what happens if we have a closed parenthesis, which is a little bit more complicated. Well, we have a closed parenthesis. That means that everything that has been read in from the open parenthesis to the closed parenthesis, we're done with that. All of the operators that were added during that time, we're done with them. So we can just go ahead and pop all of them off and add them to our post expression string until we hit the opening parenthesis. So it's a little bit of how you would do math. You would just do everything that's inside the parentheses from the beginning to the end until you're done with that, and then you would work outwards and do the rest of the math. So we need a while loop for this because we need to keep going until we hit whatever the parenthesis there is. So the open parenthesis, I mean. So we have to check that peak, that this while loop is going to run when the peak is not equal to the closed bracket, but the current is the open bracket. So when the parentheses still have yet to match up, you're going to continue your while loop. And we can just go ahead and copy paste this as well because it's just going to be the same thing, just the parenthesis shape is going to be different. And this will change to bracket, bracket. This will change to a parenthesis and parenthesis. Oops, that's the wrong thing. There we go. So again, our while loop is going to iterate as long as we have not yet matched the parentheses up together. As long as the current parenthesis in our string does not match up with the top parenthesis of the stack. And as long as this is the case, we're going to pop everything off of the stack, and we're going to add it to our post expression. So post expression, well, first off, we have to add it to our post expression before we can pop it. We can add whatever we get from the peak function, and then pop. And this is going to keep going until we hit that last parenthesis, and this should actually be correct. So the only thing remaining here to do is to actually pop the parenthesis, the open parenthesis, after we're done, because we don't have any use for it anymore. And of course, last thing we need to do is we need to decrement our present para, our present parenthesis value, our integer, because we don't have those parentheses anymore. We don't have to worry about them anymore. And so that's it for the if statement. Now the only thing that we're missing is that this right here does not actually guarantee that by the time we're done with the for loop that our stack is going to be empty. There might still be elements in the stack that haven't been popped yet. So we have to remember to include a while loop that's going to keep going until we get to the end of the stack. It's going to check while it's not empty, and as long as that's the case, we are going to add what is the top element of the stack to our post expression, and we're going to pop. And I think I dropped a parenthesis somewhere. Okay, yes, I dropped something somewhere. I think over here. Okay, there we go. And this, let me just fix the indentation on that. And so that's basically what our program is going to do. you go through every element in your current string. You add it if it's plus, or if it's if it's a digit, you add it to your post expression string. If it's a plus or minus, depending on if there's parentheses or not, you would either add them to the string, or you would just push them on the stack for safekeeping. And then at the very end, make sure that everything from the stack is added to the string, and you would eventually, at the very end of everything, return the post expression string. And that should be it for our int post function, which is the most complicated function that we have in the code. Alright, so now the last part of our stack class is going to be the actual evaluation of our postfix expression into whatever the sum of that expression is. So just adding, subtracting, etc. And this is going to be significantly easier than our conversion from infix to postfix, which is part of the reason why we do that conversion in the first place. And something that I did not mention, but is kind of important to know, is that all of the expressions that you are going to be given are going to be mathematically valid. So what that means is basically you're never going to be given an expression that you cannot solve. You're always going to have expressions that are like 2 plus 2, which we know would evaluate to 4. You're never going to have an expression that's 2 plus 2 plus and just has that extra plus or minus or whatever at the end. That's never going to happen, so you don't have to worry about that, which is really crucial to the way we're going to set this up, because we're going to make some assumptions that only work in a situation where your expression can be mathematically evaluated. So we're actually going to start writing the function now. And we want it to return an integer, because that's going to be the, when we evaluate our expression, that's just what's going to be the number that we're going to get. That's the number we're going to return. And I'm going to call my function evaluate. You can call it whatever you want. And again, we're going to take in a string of name current, which is going to be the post expression string that we just converted in our into post expression, or our into post function. So again, we can make an assumption that our evaluate function is going to always take in a post expression. Otherwise, our evaluation is not going to work. But since you, as the creator of the function and as the creator of the main class, is going to be calling this only in a situation when you've already done the conversion, that shouldn't be an issue. So the first thing we're going to do is we're actually going to need 3 integers. We're going to need an integer named sum, which is going to be the final value of all the math that you've done in the expression. And then we're going to need 2 more integers, one called 1 and one called 2. Because in any situation where you do any kind of mathematical operation, you always have to have 2 numbers. You have to have the first number and the second number. So if I'm adding, I add 2 numbers. If I'm subtracting, I subtract 2 numbers. All operations can be simplified to just that, to 2 numbers. And so that's what these 2 integers are going to represent, is going to be 1 is the first number and 2 is the second number. So the 2 numbers that you're adding, 2 numbers you're subtracting in this situation. And we actually need to make a stack for this as well. And we need this to be a stack of type string, and we'll just call it post stack. And I don't believe you need a stack for this at all, since we're working in the stack class. You can just do what we were doing in our other functions and call the stack class as is. I think for some reason we made a separate stack. So I guess just assume that this is like another example of how you could set up your program. You could make a separate stack in each of your functions, just in case something weird happens. This is going to be, a little safer way to do it. And then we need a string that I'm going to call string sum. And the reason for this is we need to do some conversions from string to int, like some convert string to int to char, blah blah blah, all that fun jazz. Because our expression as we're taking it in is a string. So this is going to help us to do that, and we'll see how we use this in a little bit. So, oh yes, another assumption that you can make is that none of your expressions are going to be just numbers. You're not going to have an expression that comes in that's just 2. That's not going to be a thing. All of your expressions are going to have an operator within them, so a plus or minus. That's always going to be the case. So that means that the first thing that we need to do is we need to make a for loop as per usual, where we iterate through every element in our current string. Gosh, I can't type. I less than current dot size, and then I plus plus. And now what we need to do is we actually have to check for if our current character is not a plus or a minus. So if it's an integer. Okay. And another thing to remember is we don't have parentheses anymore. We removed all of those parentheses in our transition from infix to postfix. Those were only utilized for order of operations. So we don't have to have any statements to take those into account. It's just going to be plus, minus, and any digits that we have. So if we know that we don't have, or we know that our current character is a digit, then we actually have to push that digit onto the stack. So it's a little bit opposite this time. Instead of pushing the operator, we push the digit. And so again, we have to remember that current at I is a character, and if we want to push it on the stack, we need to actually make it a string. For this specific case, which actually is probably the reason why we made the stacks of type string up here. Otherwise, it would have probably made the stack of type character. So we're going to go ahead and we're going to do a conversion here. This is just the syntax for this. This will convert our current character and our original string into a string. We're going to convert our character to a string because we need to convert our string to an int later on, and you cannot convert a character to an int. It's just weird syntax stuff. If you try to convert your character to an int directly, then you get the ASCII of it and not the actual character as is. So you have to convert it to a string first, and then you have to convert it to an int. So this line basically just does that. It converts our character to a string, and then it stores it in what I called current car. And then after we have that conversion, after we do that conversion, we have to remember to push this onto our stack that we just made. Okay, and that's it for our if statement. The next thing we need to take into account is, okay, what if we have an operator? What do we do if we have an operator? And in this situation, we would actually need to pop the 2 digits that are on the stack, the 2 top digits, and we need to do whatever the operation is onto those digits. So we have a plus, we have to pop the first digit, we have to pop the second digit, we have to do the second plus the first. If we have a minus, same thing, we do the second minus the first. And the reason we do the second minus the first and not first minus the second is just because we have to remember that that our stack is reversed essentially. The digit that was on top is actually the latest digit that was added and not the first digit that was added. So in order to do this, we actually have to make a string stream, which we'll remember we imported that, we included that in our stack class at the very beginning, because we're going to need this for a conversion, again, from string to integer. So we're going to store our digits, our top 2 digits, in our integer 1 and in our integer 2. And our integer 1 is going to be whatever the peak of the post stack is. And we have to remember to actually convert this to an integer so that we can perform the operation on it. So we have to use stoey for that reason. And then after we store whatever our 1 is into our, whatever our top element is into our integer 1, we can pop it off the stack. We don't have a need for it anymore. And then we can repeat the same exact thing with our integer 2. Peek at the stack, and then go ahead and pop it. Alright, and then this is the part where we have to check what our operator is. So we have to create an if statement to check if our operator is plus or if it is a minus. Okay. Alright, so if our operator is a plus, then we need to go ahead and take our sum, which is equal to 2 plus 1. And if the operator is the minus, we need to perform the operation 2 minus 1 and store that in whatever our sum is. And then after this, we actually have to convert our sum to a string, because remember our sum is an integer. We have to convert that to a string and push it back onto the stack, because the next time we do an operation, we have to do the operation on our sum and whatever number is on the stack before the sum. So we have to take in our sum with our string stream, and then we have to output it as a string, and I just called this string sum. Okay, so it has now been converted into a string, and there's multiple ways you can do these conversions, from int to char to string. There's multiple ways to do them. This is just the way that we found works, so this is just the way that we're doing it. And then the last thing that we need to do is we have to actually push the sum, which is now a string, back onto the stack so that we can continue the rest of the for loop and continue the rest of the operation. And at the end of our for loop, at the end of everything that we've done, we have to actually remember to return whatever our sum was, because that's the final evaluated value that we found. And that should actually be it for our evaluation function and the entirety of our stack class. That should be done.
So for this next part, we're going to create a linked list class with basic functions, which includes the basic constructor, the getHead function, and isEmpty function. So for our linked list class, we're going to include string and our struct class. Using namespace, std, and we're actually going to make it a template so we can throw a lot of things in there without worrying about what variable types. For our private variables, we're going to have a node head of type T. And for our public, we're going to create our constructor that just sets the head to no pointer. And we're going to create a function that returns a node T pointer, getHead. And this is just to so that when we call it from our main, we can return head. And we're going to create a bool isEmpty, and this part just checks if the list is empty or not. Return head equals to no pointer, and if it is equal to no pointer, then that means it's empty, and if it's not equal to no pointer, that means it's not empty. So next we're gonna create a add to end function, which needs the traverse list function, and add to end will just add to the very end of the list, and traverse list is actually gonna return a node pointer that points to the last node of the list, and this is just to help us create clutter within the code. Help us avoid clutter within the code and keep it nice and neat. So for our add to end function, it's going to be a void type, add to end, and it's going to receive a t type value, and you're going to create a new node of type t, call it temp, and make it equal to a new node of type t. Make temp arrow next equal to null pointer, temp digit equal to value, and then make a new node type t, call it current, and make it equal to the head. And first you're gonna check if is empty. You're gonna add to the very beginning of the list. So head equals temp. Else you're gonna traverse through the list. So make a new node type t, current equals traverse list, and send head, and make current arrow next equal to temp. And now we're going to create our traverse list function, and this is going to return a type node t pointer, and it's going to receive also a node type t pointer, call it current. So if current arrow next equals to null pointer, that means it's the last one, and we can return current, which is what we want since we're traversing to the very end of the list. And then else we're gonna call traverse list again, because that means we're not at the end of the list. Send current next. So once we're done with that, we can create a print function, which is going to be recursive, because the assignment calls for all linked list functions to be recursive. So I just noticed I had no c up here. I'm gonna change that back to node because we don't want no c. Okay, so for our print function, it's gonna be void print, and we're gonna send it a node type t pointer, call it current, and this is what we're gonna use to traverse the list. We have a string concatenate, and the reason why we have this is because the assignment actually wants us to print out the list in separate formats. So the concatenate is there so that we know what to add between the digits. That's terrible. I'm redo it. No, actually not. It's good enough. Okay. May said it's good enough. And we're gonna send a stream output, and because we're actually gonna print straight to the file output from here, and this will just simplify that instead of returning stuff to the main. So first you're gonna check if is empty as always, to make sure that you don't accidentally run into errors calling a calling the function on a null pointer. So if it's empty, you're gonna return. And this works if it's empty. If it's empty, because this current is gonna be a null pointer, and if it's empty, then it's gonna return and not go into the rest of the function, which is what you want if it is empty. So else, if current arrow next equals null pointer, then output current digit. So this is so we know that we're at the end of the list, and that way we don't call the print function again, and we're gonna return else not the end of the list. So we can do it again, output current digit, and then call the print function again. Oh wait, current digit concatenate, and call print function again on current arrow next, concatenate, and output. And that's it for your print function. Yeah. Well, this is empty, I think.
Alright, so the first part of our main coding is going to be the process of actually reading an input. And we have to actually remember to keep track of which expression goes to which twin. We don't know how many expressions we're going to be given for each twin, and we also don't necessarily know what order it's going to be in. So you could have Sarah be the first person and have like 5 expressions under her name. And you could have Alex next and have 1 expression. And then you could have Alex again and have 3 expressions. So it's a little bit random, depends on what your input is going to be given. So we're going to need a while loop for that, and we're going to need some if statements to do this. So I'll go ahead and go over to my Visual Studio. And so of course, first thing we're going to need is to import some things. We're going to have to include our IO stream. Going to include our F stream. And we're going to include our string. And I'm not going to do this with Argument Manager. I'm just going to do this with just cin, cout, or not cin, sorry, but just if stream and cout. Or upstream. Sorry, we're going to use cout for testing, but you could also do that with upstream. It doesn't really matter. If you're doing it with Argument Manager, you'd have to make some slight alterations, but we're just going to do it with cout because that's how I prefer to do it. So we can include, of course, our linked list header file and then our stack header file. And we don't have to worry about including a struct because that's included within our other classes anyways, and we don't really need to access it in our main. And so remember our namespace std, and then our main. Remember to return 0 there, and we have to declare our if stream input. We'll just do input.txt, whatever your input name is, you can do that. Whatever your input file is, you can name it whatever you want. For command, and I will actually not use cout. I'll use output. I'll use our f stream. I personally prefer cout because it's easier to use while you're testing and then just change things afterwards. But just to keep everything kind of formatted how you would normally want it formatted, we'll use upstream. And then the next portion of this is going to be creating our variables. We need a variable for whatever our current input is that we were reading in, and then we need a variable for whoever our current person is, because we have to remember to add to the correct list for the correct twin. So we have to keep track of which twin we're actually at. And then we need a string for our passcode, because at the very end of each of the input files, it tells you what the passcode is supposed to be. So this is where you're going to store it. This is a string you're going to store it in. And then we also need a number or an integer that we're going to call num invalid. This is going to keep track of how many invalid expressions we have, because if you'll recall from the document, that's something that we're going to have to use at the very end and remove whatever integer, whatever digit is at that specific index. And now we have to make a stack to store our negative numbers in. If you'll remember that was something that we had to do. We have to figure out where the negatives. Oh, my stack is not capitalized. We have to figure out if the answer to our expression is negative, then we have to remove it from the final list. So we have to actually remember to add that into our temporary negative stack. I think I called it neg stack in the little PowerPoint, which is a little bit of a silly name. And then we need to do our linked list for each of the twins. It's going to be Sarah list and Alex list. That's just what we're going to call. And it is yelling at me. Oh, I do not have the linked list class written. Erik is doing that portion, so that's why it's going to have these red highlights under them. Okay, so now onto the actual input rating part. Of course, we're going to have a while loop for this, and we can do our while loop while the input is not at the end file. We're going to create a temporary stack of type car that is going to that we're going to pass through to figure out if the expression is valid or not, and we're actually going to use this for our conversion itself. So this stack is going to be used to convert whatever our expression is. We just call this parenthesis valid because that was just what we called it at the time. Bit of a misleading name, but you can call it whatever you want. And then we can do our get line taken from our input file, and we're going to store that in whatever our current input is. And my stack is not capitalized as it should be, but I'm going to fix it. And then we need to make sure that we don't have any white spaces, or that we don't accidentally take in the white spaces and try to perform operations on them. So we have to eat up the white spaces, which is what this line is going to do. Okay, so now we have to get into a series of different if statements, which is a little bit weird. If our current input is equal to Sarah, then we need to make Sarah the current person. So if our current input is not an expression, but it is a person's name, then we have to change who the person, who the current person is as of right now. Of course, we have to do the same thing with Alex. So if the current input is Alex, then we need to change who the current person is. Now, if the input is not Alex or Sarah, but it is an actual expression, if the input is an actual expression, then we need to check if our current person is Sarah or Alex. If the current person is Sarah, then we have to make alterations to her linked list. If the current person is Alex, then we have to make alterations to his linked list. And we'll fill these out in just a second. But we're going to have this outlined first before we do that. And I actually forgot an else statement here. This should be an else if. If we find the word passcode in our input, which if you remember correctly, that's the last line of all of the input files. It's going to contain the word passcode, and it's going to have whatever the passcode actually is. So if we find that the file contains the word passcode, or that the line contains the word passcode, then we have to check then we have to set whatever our passcode is equal to our substring from where the passcode starts, which is at the colon +1, and then all the way to the end of that string, which is what our which is what this part is going to do. And this is a little bit of syntax if you're not familiar with it. This line right here for else if, it will check to see if the word passcode is present. If the word passcode is present, then you're going to return a value that is the starting index. So wherever the P is found, that's the value that's going to be returned. Otherwise, you're going to have either -1 returned, or as you'll see here, this little weird thing right here, it's going to check if there is a value returned at all. And then line 33 over here is for a substring. It will cut, a substring will cut from where it finds the colon in the index after the colon, and it will go from that index all the way to the end, and that's where our passcode is going to be stored. And it doesn't matter for your passcode to be a string or an integer or whatnot, because it's basically going to be printed out as is. So in this situation, our passcode is a string. It doesn't really matter. You can make yours an int. Just seems a little bit like extra work when ultimately you're not actually performing any operations on it that would matter. So that's it for the basic setup for the while loop. We're going to fill in this if else if in just a second, but this is going to require us to call a function that we are about to write that we have not written yet. Alright, so the next part of our main coding is going to be calling the add to list function, which is a function that we're actually going to have to write before we can call it, which is going to add to the correct twins list. It's going to increment the integer number invalid as is needed, and it's going to push any negative number for expression to our negative stack. So this is basically going to do most of the dirty work in main for us. So I'll go ahead and go to my main, and we'll just make our function up here. And we don't need it to return anything, so we can just make it of type void. And it's actually going to take in quite a few parameters. It's going to take in the list. It's going to take in a linked list of type int, which this list is going to be either Cyril's list or Alex's list, depending on when we call the function, where we call it. I'm just going to call it my list, and we want to pass it by reference because this add to list function is going to permanently alter their list. And then we need to pass in our negative stack. We can call that negative stack, and again, this is also going to be passed by reference because we need to make sure that that's also permanently altered. And I keep forgetting to capitalize my stack in my list, but that is kind of important. And then I need to pass through my pair validity stack because we have to actually call on the functions from the stack class to perform all of the functions for our expression. We have to call that within our add to list function, and this one doesn't need to be passed by reference because it's going to be remade every time. Every expression is going to be evaluated separately from another expression, and then we have to actually take in whatever our expression itself is that we want to perform the evaluation on. And then we need to take in our integer invalid, which is also passed by reference because that should be permanently altered. And so that's a very, very long list of parameters. It's like 5-6 parameters. So the first thing we're going to do now is we're actually going to make an integer we're going to call decoded. We're going to set that to 0. And this is going to store whatever our value is from our stack. After we perform all of the, the check and validity, infix to postfix, and then the postfix evaluation. This is where our evaluated expression sum is going to be saved. And we're going to make a string as well that we're going to call postfix, and this is where we're going to temporarily save our infix to postfix conversion before we convert it before we evaluate it to the final answer. And so then I need an if statement to check if the expression is valid or not. So we can call check validity on my stack, which is the one that again we're using for most of this for most of these conversions, and we can pass through our expression as a parameter. And if we find that the check validity is true, then we have to go ahead and proceed and convert our postfix, or convert our infix to postfix, and save it into our postfix variable. So I'll call my into post function, and then I need to call my evaluation function on the postfix expression and store that in my integer value decoded. And now that we've actually decoded our expression itself, we have to double check what the value for decoded is. Because if the value is negative, then we have to push it onto the negative stack. Oops. And then otherwise, if the value is positive, then we want to add it to the list. And again, most of this stuff is in the instructions. If you don't remember in the instructions, you can always go back in the video and double check and see what it says. But that's what the instructions tell us to do, is to add the positive elements to whatever the list is. Again, we're gonna pass Sarah lists, Alex list in our main. We can just assume that this is passed correctly and add it to the list as is. And now we have to remember, in a situation where check validity over here, this evaluates to false, we need to add that statement. If check validity is evaluated to false, oh, sorry, that's incorrect. If check validity is evaluated to false, then we need to increment the number of invalid expressions. And that is actually going to be all we need to do for our add to list function. The only thing remaining is our call to this function. And this call is going to happen every time we read in an input and we find that it is an input that is an expression. So we can go back down here to our if and else if statements, and we can say, okay, if the current person is Sarah, then call the add to list function and call it on Sarah's list. And then we have to pass through our negative stack to save our negatives. We need to pass through our temporary stack that is actually going to make the evaluation. The temporary stack is actually going to do the evaluation for our expression. We're going to pass in whatever our current expression actually is. And then we're going to pass in our number invalid. And we need to do the exact same thing for Alex. The only difference is going to be for Alex that we have to pass in his list instead of Sarah's list. And so that's going to be all we need to do for this portion of the code.
Alright, so up next we're going to create a delete value function, which is going to delete certain values. For this assignment, we're going to delete negative values. And we're also going to need a helper function, which is delete at beginning. So if it is at the beginning, we're going to call this function just to make it easier for ourselves. And both of these functions are going to be recursive. So first we're going to create the delete at beginning function, which is actually pretty simple. Delete at beginning, no arguments. And you're going to check if it's not empty first. is empty, because you don't want to delete at the beginning if it is empty, because you're going to be deleting a null pointer and that's going to give you errors. So you're going to create a no type t pointer, call it temp, and make it equal to the head, because you're going to switch the head to the next one and then you're going to delete temp. So, and then head equals head arrow next, and then you can delete temp. And that's it for the delete at beginning function. And next we're going to create the delete value, and we're actually going to make this a bool function, because we need to know if we found it in Sarah's list or if we found it in Alex's list. And we're gonna, the arguments are going to be a type t value, a node type t pointer, call it current, and a node type t pointer that's going to be equal to previous, so we know where we're at all times. So first you're going to check if current is equal to no pointer, then we can return false, because that means we traversed the whole list and we didn't find it, and now our current is no pointer and it's going to return false. This also works if the list is empty, because you're going to send a no pointer to the delete value function, and it's going to automatically go to this very first part right here. So it works for both cases. Else, if current arrow digit is equal to value times -1, because we're actually going to be deleting the counterpart of the value we send, and so we need to check if it's equal to the negative. So first, if previous is equal to the no pointer, then that means we're at the beginning of the list and we can delete at the beginning. Call our delete at beginning function. Delete at beginning. Else if previous is not equal to no pointer, that means we're not at the beginning of the list, and we have to create a new node type t pointer, call it temp, and make it equal to current, because you wanna mark it first before you delete it, and then make previous arrow next equal to current next. So that way you actually link the previous to the current next, and you don't create any gaps within your list. And then you can delete temp, and that's it for that part. And then if we got to this part right here, then that means we found the value and we can return true. And if current digit is not equal to the value times -1, then that means we need to keep going. We need to keep traversing the list. So else delete value. I'm gonna pass the value, current next, and current, so we can keep traversing the list recursively. And that's it for our delete value function. So then we're gonna create a merge list function, which is actually gonna take Sarah's list and merge it to Alex's list and make it one complete list, and then pass it back to the main function. So for the merge list, we're gonna make it a type void, because we don't need to send anything back. We're gonna do it by reference, and then for arguments we're gonna send it a linked list type t, by reference Sarah's list, because we're going to permanently alter Sarah's list, and then another linked list type t, and call this one Alex's list. So first, you're gonna want to check if Sarah's list is not empty. Because the steps are a little bit different if it is. So if it's not empty, then we can make a new node type T pointer current and make it equal to Sarah's list get head. And this is gonna make current equal to Sarah's list head. And then we're gonna make current equal to Sarah's list very last node, because this is how we're gonna link the two lists together. And we're gonna send it current because we need something to pass onto it. And then once we have the very last node, we can make current arrow next equal to Alex's get head. And this works even if Alex's list is empty, because it'll just make current arrow next equal to no pointer, and that's still valid because it's the very end of the list, so it wouldn't cause any issues. Else if Sarah's list is empty, then we're actually going to add to the end of Sarah's list, make it not empty, and we're gonna add Alex's very first digit. So Alex list get head arrow digit. So we're getting through the fact that Sarah's list is empty because we're passing Sarah's list by reference back to the main, and we need to make it not empty to make that work. So then we're gonna make a node type T pointer current equal to Sarah's list get head. And then we're gonna delete the very beginning of Alex's list because it's been added to Sarah's list, and we don't want any duplicates. Delete the beginning. And so now Alex's first node is now belongs to Sarah's list first node, and we're gonna delete Alex's first node. And then we're gonna make current arrow next equal to Alex's list dot get head. And this works because current is currently equal to Sarah's list head, and so it's the last node anyways, because we made it not empty and it only has one node, and we're gonna make that equal to the very beginning of Alex's list, which now starts at his second node. So once we've created the merge list functions, then we can create the delete at position function, which is just gonna recursively look for the node at a position to delete. So our delete at position function is gonna be a type void delete at position, and for the arguments you're gonna need a int position, which is gonna be the position at which we're gonna want to delete, a node type T pointer current node type T pointer previous, so that we can link the previous to currents next and not create any gaps within our list, and then an int count to keep track of how many times we've gone through the function, because it needs to be recursive. So if position is equal to the count, then that means we've found the position that we wanted to delete at. but because they might give us positions that are bigger than the size of our list, we need to make sure that it's not equal to null pointer, so we don't delete a null pointer, which is going to cause problems. So if it is equal to null pointer, return. Else if previous is equal to null pointer, then that means we're at the beginning of the list, and we can delete at beginning. And else if current is not equal to null pointer and previous is not equal to null pointer, then that means we're either at the end or somewhere in the middle of the list. And else, let's make it else. Oh, else if, I'm sorry. Else, create a new node type T, call it temp, and make it equal to current. Make previous next equal to current next, and this is just to prevent any gaps within our code, and it works even if current next is equal to the null pointer, because it'll just make previous next equal to null pointer and making that previous our new end of the list, and that's still valid. And then once we've done that, we can delete temp. And if we're at position equals count, then that means we can return and exit out of the function. Else, we're gonna call the function again, delete at position, give it position, make current next, previous, and then current, and count +1, so we can keep track of how many times we have left to go through the function. And that's it for your delete at position function. So once we're done with that, we can create the reverse list function, which is going to go to the very end, make the last node equal to head, and then make all the previous nodes equal to the previous. We can make our reverse list type void, and for the we're just gonna need a node type T pointer for the argument. Make it current. So if is empty, then that means there's nothing to reverse, and we can just return. Else, so this first part, we're gonna check if current next equals to the null pointer. That means we're at the end of the list, and we can make head equal to current, and then return. Oh wait, yeah. And if current next not equal to null pointer, then that means we're somewhere in the middle. Else, we're gonna call reverse list on current next, so we can keep going through the function. And we're gonna create a new node type T pointer, call it temp, and make it equal to current arrow next, and then make temp arrow next equal to current. So what this is doing is making temp equal to current next, and then pointing temp back to current. So it's like a little swing kind of. And then once we can make current next equal to null pointer, because it no longer needs to point forward, only backwards. And that's it for our reverse list function.
Alright, and now we can move on to the part 2 of coding from the main. And the first thing we need to do is we need to delete all of the values from the negative stack from Alex and Sarah's lists. So if you'll remember, the negative stack was the stack in our main that saved whatever negative values we got from evaluating our expressions. And now that we finished going through all of the inputs and we've saved it to Alex and Sarah's lists as we need to, we actually have to go back through the negative stack and remove any inputs that match up with the negative values from the list. So if I have a value of -2 in my negative stack, I need to remove the value of 2 from Sarah and Alex's lists. And if you remember from the directions, what we need to do is we need to start from Sarah's list. And if Sarah's list does not have the value, we check Alex's list. If Alex's list does not check the value, then we're done. Otherwise, if we do find the value in that order, then we remove it from the first position that we find it in. And so the code for this is actually pretty short, pretty sweet and simple. We need to do a while loop, which is going to check that our negative stack, or store negatives as it's called, is not empty, because we need to make sure that we remove every value that is found in that stack from the list if it's found. So as long as the stack is not empty, we're going to go ahead and make an integer current, which is going to just store whatever our peak value is from the stack. And we're going to check to see if Sarah's list actually has the value that we want to delete or not. And we have to pass through our parameters. We pass through our current, which is the value that we're going to delete. And then we need to pass through Sarah's list's head. And if I think I added, did I add an extra? Oh, I'm sorry, I forgot. We actually have a third parameter, which is going to be null pointer. And if this returns false, then we know that Alex's list is going to have to be checked afterwards. So again, we pass in the same parameters, just slightly altering them so that it's Alex's list that gets passed instead. And this not only checks to see if the value is found, it also will delete the value if the value is found. And so we can assume that the value has been deleted. Now, if it has been found, if it's not been found, it doesn't matter, we're not going to do anything. And then we need to remember to pop the value from our negative stack. So that we can go back through a while loop and do all of this again with whatever negative value we have stored in the stack afterwards. And you don't need to use a stack. I don't know if I mentioned that. You don't need to make your negative stack a stack. We just did that because we wanted to. But you can make it a linked list as well. You can make it an array. You can do whatever you want. Just some kind of list that you can easily access that will let you store your variables or store your negative values until you need to get to them again. And this should actually be it for the removal of the negative values from main. Alright, so the next part of our code is going to be printing Sarah and Alex's list, which should be pretty easy since we have our print function already made in our linked list header file. So let me leave my while loop right here. So the way it wants us, the formatting that it wants us to output it is we want to output Sarah, and then we want to output our little bracket, and then we want to call the print on her list, and of course provide it with a node to start off with because it's recursive, which is going to be head. And then it wants to know what we want to add between each of the values, which is just going to be a comma. And then we want to give it our output of stream in order for it to work. And then we need to do the same thing with Alex's. we need to close up series list first and add a new line, and then Alex. Okay, and then call the print function on his list as well in the same format. Alright, and do a comma here, and pass through our output of stream, and then just close that up as well with our bracket and a new line. Alright, and now the next portion is going to be merging the lists and then deleting at whatever the number invalid count is. So we can just call the merge list function, and because we want Alex's list to be added to Sarah's list, we'll call it on Sarah's list. Which means that from now on, we just have one list and it's stored in Sarah's list. So any other function we call on the list should be called on her list and her list only. So we pass through Sarah's list and Alex's lists as parameters, and then we check to see if the number invalid is greater than 0. Because if it's equal to 0, we don't alter anything. But if it's greater than 0, then we need to delete at whatever the position of number invalid is. And so we have to call our delete at position function, pass through our number invalid, pass through Sarah's head, because that's going to be the node we start counting from, and then pass through 0, or pass through null pointer, and then pass through 0. And that should be it for merging our list and deleting at the specific position. Alright, so the next part from this is going to be reversing the list and then printing the total list. So we can do this pretty easily, just as well. Most of this is pretty easy at this point. It's just calling on your function and just a little bit of formatting. So what we're going to do is we're going to print out whatever our decoded passcode is. Alright. And then we're going to call our reverse list. And we need to call it on Sarah's list again because everything is contained in her list now. We're going to reverse it, and then we're going to print it out and pass through get head, and formatting is going to contain our little or. This time, I'm not sure what that's called. I'm just gonna call it an or, but the little like vertical line, and pass through our of stream, which is called output, and then we want to print out the rest of the formatting, and add our new line. And after that, we're going to want to print the actual passcode that's given in the input file. And this time, for the actual passcode, we can actually do a for loop for this. Pretty simple. So we'll just tell it that we are printing out the actual passcode, and then do a for loop. It's going to start from 0 up until whatever the size of the passcode is. The size of the string that contains the passcode is. And then if we're not at the last digit, then we have to output the passcode at I, and also add our little line in a space before and a space after. Passcode at I, and then space before, space after, and then else, if it is at the last portion of the passcode, or at the last character of the passcode, we want to output that, oops, that was not right. We want to output that as a space, and then a line, and then no space after that. Again, just the way it wants it formatted. If you don't remember, you can always double check on the, on the group assignment sheet that we showed at the beginning of the video. And this is actually it. This is the end of our program. we finished our stack, we finished our struct, finished our linked list, and we finished our main. And if you run this program now, then you will see that it's going to output exactly what it should output, and you're going to be good to go. So